Hi, I'm Leona Lassak from the Ruhr University in Bochum.
And I'm Annika Hildebrandt from the University of Chicago.
Together we'll be presenting a series of user studies related to the FIDO2 WebAuthn protocol, which enables users to sign into websites using their fingerprint or face. Imagine you sign into a website, say eBay, on your phone and see this notification. Tired of passwords? If you use your fingerprint, face, or PIN to sign in to your phone or tablet, you can now use it to sign into eBay. That sounds pretty convenient, but it might be scary to send your fingerprint to eBay, right? This is not actually what happens, but a first-time user might have that misconception. Using biometrics to sign into websites is part of the FIDO2 project, specifically the WebAuthn protocol. The overall goal is to replace passwords for authentication on the web. We focus on using biometrics to authenticate, which we term Biometric WebAuthn. However, you could also use your phone's unlock PIN, for example, or even a security key. Behind the scenes, WebAuthn is based on public key cryptography. So to register on a website, a public-private key pair is created. The private key is saved on the user's device, and the public key gets stored by the website. So when a user tries to sign in, the website sends a challenge to the user's device. And when the user provides their biometric to their device, they authorize the use of the private key to sign that challenge. So what is essential here to understand is that the biometric data never leaves the user's device. To summarize, WebAuthn's main advantages are authentication using biometrics is very fast and convenient. Also, unlike passwords, there is nothing to remember, and the protocol resists phishing attacks as well as password reuse or credential stuffing attacks. So overall, we feel that WebAuthn using biometrics holds great potential to replace passwords on the web. But whereas you just saw WebAuthn's inner working in detail, a first-time user has only ever seen this. We call such a screen a notification, and all the user knows is that they can now sign into eBay with their fingerprint or face. However, in order to actually replace passwords on the web, we must convince users to switch to WebAuthn. Short notifications like this are thus critical to convince users to adopt WebAuthn, which is also what our studies focus on. Overall, we conducted 3 related user studies. The first one aimed to identify users' misconceptions about biometric WebAuthn. The second aimed to design new notifications that addressed those misconceptions. And the third one was an experiment comparing the new notifications designed in study 2. Next, we'll take you through each study in detail. So in our first study, we had 42 crowd workers register for and also sign into our own website with biometric WebAuthn on their personal devices. To capture our participants' initial expectations, we just showed them a simple, vague notification saying they can sign in with their fingerprint, face, or iris. During the registration, they saw their phone's native WebAuthn Verify Your Identity screen. And in our follow-up survey, we then asked questions quantifying potential misconceptions, as well as covering perceptions of usability and security. A week later, we then had participants log in and answer some further survey questions. Seeing just the simple notification, which is also a typical example of notifications currently used in practice, we found that 67% of participants incorrectly thought their biometric data would be transmitted to our website or a third party. 43% of participants incorrectly thought that biometric data would not be safe from an attacker who might steal data from the website's database. Participants also raised usability concerns, especially what would happen if they can't log in with their fingerprint. So, while in reality, WebAuthn lets them use their PIN or pattern as a fallback mechanism, they would have no way of knowing this. So, unsurprisingly, 93% of our participants did not expect that they could use a non-biometric fallback in case the biometric would fail. And this also highlights how notifications must address users' concerns and misconceptions early on.
Having documented these misconceptions in Study 1, we wanted to design better notifications. We conducted co-design focus groups in which non-expert end users helped us design notifications they thought would be understandable and focus on WebAuthN's key advantages. We held 7 remote focus groups with 29 participants in total. The co-design technique lets non-technical end users contribute valuable insights about what might convince them to adopt biometric WebAuthn. It also lets them challenge the researchers' implicit assumptions and preconceptions. We started Study 2 by explaining in great detail how WebAuthn works. We then presented a video that showed the basic functionality of biometric WebAuthn. We then collected the participants' first impressions of what they had just seen. We then supplied supplementary reading that explained the inner workings of WebAuthn in detail and answered their questions. Having helped our participants understand how biometric WebAuthn works, we had them identify the information they thought was most important to include in a short notification to convince others to adopt biometric WebAuthn. Specifically, we asked them to design their own notification that would fit on a phone screen. The entire group then discussed everyone's notifications and approaches. Participants focused on 4 categories of information. The first was the convenience of WebAuthn, emphasizing how fast and easy it is to use with biometrics. In the security category, terms like safe and secure were mentioned frequently. Participants also emphasized the storage location of the biometric data, specifically by saying it's only stored on your device, it never leaves your phone, or that no one except for you has access. Some participants wanted to mention that the WebAuthn protocol was co-developed in part by popular brands like Google or Apple, while others disagreed. Third, participants made comparisons to passwords. They emphasized that there's no need to remember a password, or that passwords are easy to hack. In the availability category, participants felt it was important to mention that you cannot easily access your account from a different device unless you specifically register it.
So, now that we had designed those new notifications, we compared them in our third study. Similar to Study 1, we had participants log in with biometric WebAuthn and answer survey questions. However, this time they were randomly assigned to one of 8 groups that specified how they would authenticate, as well as what notification they would see. 6 groups in total registered using biometric WebAuthn. One group saw this control notification saying only fast and easy sign-in with your fingerprint or face. The other 5 biometric notification added to this control notification. Our stored notification mentioned that the biometrics is only stored on the phone. Shared says that the biometric is never shared. Leaves mentions that the biometric data never leaves the device. Hacked explains that, unlike passwords, biometric WebAuthn can't be hacked. And Brands mentions that biometric WebAuthn is backed by Microsoft, Google, and Apple. We also had a non-biometric WebAuthn condition where participants signed in with their device's unlock PIN or pattern, as well as a regular site-specific password. In our survey, we asked participants how secure they perceived the login they had performed to be. The shades of green on the top represent people who felt the login method to be secure. Red at the bottom represents those who did not feel secure. The 2 bars on the right represent the non-biometric WebAuthn with PIN or pattern, as well as the site-specific password. And we find that these 2 conditions were rated least secure. so that the biometric WebAuthn was consistently perceived as more secure is an encouraging result in terms of adoption. Our survey also had a within subjects comparison where all biometric participants provided feedback on all the different notifications. Here we found that participants felt the stored and leaves notification made them feel most secure. Lastly, the misconceptions. In our control notification, which contained no extra information, 66% of participants thought that the biometric was sent to the website. However, the notifications stored and leaves reduced the percentage of participants who had an incorrect mental model thinking the biometrics would leave the device. So, while we acknowledge that there's still a long way to go, we also see that just a short one-screen notification caused a meaningful shift in perception. In summary, we identified important misconceptions surrounding where the biometric data is stored with biometric WebAuthn. Nevertheless, we found that it was perceived very positively, and participants indicated that they would be happy to use it for their personal accounts. We particularly recommend notifications emphasizing where the biometrics are stored, and it is also important to emphasize WebAuthN's speed and ease rather than just comparing it to passwords. Thanks a lot for your attention, and we'll be very happy to answer any of your questions.